Okay, just let me remind you where we are now. This is week number 9, module 3, and we already completed the first 2 topics. These are the vector calculus and matrices. Now we are discussing until the end of this semester the differential equation, first and second order differential equation. Last week, week number 8, we started with the terminology, definitions. I revised also for you the integration. We already studied integration in semester 1. We revised them. And then we moved to the methods used to integrate, or let me say to solve differential equation first order. The first method is separable. We solve few examples. I will continue today with this, just more examples to be solved here. As you can see here, follow me here. dy over dx, okay? You can see y here, sorry, over dt, and t here on the same side. I need to separate them. So I will divide by y here by y. So you see here, cancel y with y. I want dt to be at the other side, to the right hand side. I will multiply by dt by dt. You cancel here with here. What is left? dy 1 over y and sine t dt. I separated them. Now I can integrate. The first one to the left will give me ln, as you can see here. Now we are familiar now with integration. And the second one is integration of sine is minus cosine, as you can see here. Now I need to make y as a subject, sorry. So what I will do, I will take exponential here and here. Okay, exponential with ln, what is left? Y. And this one, exponential for the whole expression here, it means exponential minus cosine t dot exponential c, right? I can separate them because they are power now. Now this one, I can call it a as example, constant. So I can put it in front here. So what I got, y equal a exponential minus cosine t. This is the solution. If I want to check, I will differentiate. If I differentiate, I should back to the original expression of the first order differential equation. Another problem here. You can see now it's easy to do cross multiply. Cross multiply. I will have y on the left hand side and x on the right hand side. Now we can integrate both. When we integrate this one, y it will be y squared over 2. 1 it will be x, and here it will be x squared over 2. 2 with 2 it will be x squared. Now I can multiply by 2 to simplify. Okay, now I am here. By the way, you see, because I integrate left hand side, right hand side, I can put 2 constants, but at the end I will combine them in one constant. So I will take this to the other side, will be c2 minus c1. I can call them directly c. So no need to every time you integrate to put many constants. Just at the end put one constant to tell the full story that there is some constant maybe there and has been differentiated and becomes 0. Another problem here is, as you can see here, dy over dx equal in this way, dy over dx equal x squared over 1 minus y squared. Also, I can cross multiply and integrate. It's easy to integrate x squared, 1, y squared, all of them easy to be integrated, as you can see here. Sometimes, as I mentioned last week, we may have x and y came together and there is a plus between them or minus. Now, plus and minus is difficult to separate. So what we need to go for substitution. We go for assumption. As example here, what I will do, rather than my equation become y and x, I will make it v and x. So I can integrate and then return back and substitute for yx. Have a look here. Now, when x and y came in this way, I can assume as example y equal vx in this way. So this y, it will be vx. You can see I can cancel x from numerator and denominator. What is left? 1 plus 3v over 2. Now this expression contains only v. Got it? Now also I need to convert this dy over dx into v. I mean, differentiate this one, it will be dy over dx equal, differentiation of x is 1, so v plus x. Differentiation of v is dv over dx, right? So I will take all expression here and substitute it here, as you can see. All this equal 1 plus 3v over 2. Take v to the other side here, it will be minus v. Algebraic, okay, addition, okay, we will come up with 1 plus v over 2 equal x. Now I can separate, you see, I can separate. I can write it in this way, 2 over 1 plus v dv equal dx over x. Now here x, here v, I can integrate now. You may say, okay, you integrated, and next step, okay, we need to back to y. So at the end, whatever v you come up with, you need to substitute for v from here, v equal y over x. Let's solve some problem. Have a look here. Have a look here. Now I will practice with you. Okay, this is clear. We can just we can divide. Sorry, here I will write it here. dy over dx equal y over x. I want y to the left hand side. So what I will do, I will divide by y. Cancel this. I want dx to be to the right hand side. I will multiply by dx. What is left? dy 1 over y equal 1 over x dx. Now it's clear that when we integrate, we come up with ln. So ln y equal ln x. As I mentioned, always try to put one constant. Now I want y, take exponential. It will be y equal exponential ln exponential c. I call it a, then which is a exponential, sorry, ln with the x here. Ln with x will be x only. Okay. Now let's take another example. Let's take another example. Okay. This one. Or let me clean the board. Okay. I will give you a problem to solve. Just let me solve another one. As usual, I take the easy one. I give you the difficult one. Oh. Okay. Now let's take another one. Let's take another one. Just 1 second. I will take this one. Okay. This one I can cross multiply. Okay. So it will be 4y to power 3 dy equal exponential 2x dx. Now it's clear that I can integrate. Okay. So what we will have y to the power 4 over 4, and there is 4, we can cancel them, equal, sorry, 1 over 2 exponential 2x plus c. Now I can take the fourth root for both. Y will be root number 4, 1 over 2 exponential 2x plus c. It's really easy, right? Now, what I want you to do, I want you to solve this problem number 10. But before we go, let me explain it to you. Okay, this is equal 0 plus equal 0. Let's erase this one and say directly equal minus exponential t plus z. Now my variable is z. It was differentiated with respect to t, and they came here together, t and z. What do you think? What we should do?
Maybe we do
Take ln.
e to the power t dot e to the power z.
We separate them. Okay, let's go equal minus e to the power t e to the power z. Next,
Then
we can
we divide. We
Yeah.
divide by e to the power z to both sides.
Excellent. You see, we can go for what she say. Your colleagues, what she say. She used the properties of indices. Here plus, I can spread them. So what I want to say from this example, okay, continue working while I'm talking. Okay, work on it. I want the final answer. Okay, but what I would like to highlight here, always start simple steps and go for the properties which could simplify your problem, and then you solve it. You don't need to expect always that your problem is complicated, or you take it as a one piece, split it, simplify it, it will be clear in front of you, and then you can direct solve it. So you say dz over dt equal minus exponential t dot exponential z. Okay, I want the final answer.
Z equal minus t.
Z. Who's this? Who's talking with me? Z equal? Asil. My Z equal minus?
T.
Just minus t without constant?
Yes.
Plus
Constant.
Plus constant. Okay. What do you think? Anybody have an idea? Is it okay?
Yes. It's Z equal T plus C.
T plus C. So you say without minus, right?
Minus.
Without
Yes.
minus. I want to listen to more people who solve it with minus or without minus.
Without minus, I think.
Without minus?
without minus.
Without minus. Okay. There is minus in the question here. Okay. So let me do it. Have a look. It will be exponential minus z. Okay. dz equal minus exponential dt. Okay. dt. When I integrate, okay, this one will give me exponential z equal and minus, definitely. Just a minute. Minus. I need to provide minus, so it will be. And here minus exponential t plus c. Am I right? What do you think? Correct? Here exponential minus z, because I move it to the other side. Okay, so it becomes exponential minus z. When I integrate it, okay, it will be minus exponential minus z. Minus z. On the other side, minus exponential t plus c. Okay, now minus here will reflect here, okay, because exponential, okay, or I can multiply by minus, since here minus and here minus, it will be exponential minus z equal exponential t minus c. Okay, now I want to have ln here, ln here, okay, in this way. So ln with exponential, it will be minus z equal ln exponential t minus c. Can I enter ln to them, or they are one expression? One expression. So this minus can be by multiplied by minus 1, it will be minus here. You see? You see, I mean, you know how to integrate for exponential. But this stuff, I mean, minus, plus, transferring from left-hand side to the right-hand side, always you get mistakes in these type of operations. So my advice, no, work in steps, organize your solution, and make sure whatever the operation you apply should be justified. Okay, any operation you apply, it should be rule, you justify it. Okay, now just a minute, one second.